Well, in this very beautiful experiment, we will transmit electricity without wires. For this, we need to make a small circuit. This converts electricity from the mobile charger DC into AC current. This project was made by several students of the New English School in Pune. This historic school was set up by Lokman Tilak in 1880. The power supply is a Nokia mobile charger and it is connected to a 220 volt AC mains. The input goes through an electronic circuit. Instead of a PCB, we have assembled the circuit on a transparent sheet of plastic. The circuit consists of a transistor, 3 capacitors and a resistance. The red one is a 1 NF capacitor. The green one is a 4.7 NF capacitor. The resistance is 5.6 K and the transistor uses DD139. The yellow one is a 100 NF capacitor. The green coils are actually 2 coils with 5 turns each. So one coil will have 10 turns and the other will have 5 turns. There is a live wire and a neutral wire. The circuit basically converts the DC from the Nokia charger into an AC current. Because the AC current fluctuates, it produces a spinning magnetic field in the green coil. Now my name is Ratnakar and my friend Nachiket just gave you information about the primary coil. I will tell you more about the various secondary coils. Now this green coil converts the DC from the Nokia charger into a spinning AC and this creates a spinning magnetic field. Now there are various secondary coils. We are going to make 4 different secondary coils in this experiments. Coils with various numbers of turns and various capacitances. Now this is the secondary coil which is made up of 5 turns of insulated copper wire. It's got a 15 NF capacitor attached to the coil. The yellow LED is also attached parallel to the capacitance. Now when we bring the coil near the green primary coil, it induces a current is induced in the secondary coil and the capacitance gets charged and the yellow LED glows. You can see the yellow LED glowing. Now this is truly transmission of electricity without using any wires. You don't need to connect the primary and the secondary with wires. Now this is the second secondary coil and it has 10 turns of insulated copper wire and 4 small capacitances attached in parallel. The capacitors increase the strength of the coil and there is a red LED. This time is going to light up much more brightly. As you bring the secondary coil near the primary coil, you can see the red LED light up and you can lift the coil slightly up and even from a large distance it will light up. Now this is the third coil, secondary coil, and you can see there's got 20 turns of insulated copper wire and 3 small capacitances attached in parallel. One capacitor is 30 NF and the other 2 are 20 NF each. There is also a LED attached. This increases the strength of the coil further. You can lift this coil up and the electricity transmission will still take place. The earlier 3 coils had capacitors. Now we take the 4th coil which just has 25 turns of insulated copper wire with no capacitors at all. And there are 3 LEDs which are attached in parallel. But despite no capacitors, wireless electricity will still be transmitted to the coil and all the 3 LEDs will light up. But because there are no capacitors, the capacity of this coil would be slightly limited. Now, once you bring this coil near the green primary coil, all the 3 LEDs will light up. Now you can see, if I remove all the 3, the coils are lighting up, but if I remove the intermediate coil, the one which is further away switches off. Which means sometimes we need an intermediary coil. From the primary it goes to the intermediary and then to the further coil. My 2 friends told you something about wireless transmission of electricity. Here is this green primary coil which has an oscillating, an AC current, and which is a spinning magnetic field. If I bring a secondary coil near it, the LEDs light up, as you've seen in the past. Now imagine I take a very strong magnet from a speaker, and if I bring it and I place it in the well of the green primary coil, the strong magnet of the speaker will absorb all the magnetic radiation and the coils will dim and shut up. This is another very nice experiment you can do with this.